So when you open the electrical box, there is a printed thing. When it is a genuine compressor, generally you have a printed one. If it is a duplicate compressor, you don't find anything. It will be a plain thing. Because when they are copying also, they are not copying 100%. Like they copy part of it and leave part of it. Yeah. Similarly, when it comes to the T blocks, the genuine one has all these part numbers printed there and all that. The duplicate one doesn't have all this. So when you open it and see it,
yeah, this is good point.
Huh?
This is good point.
Yeah. So one more thing is on even rubber plugs. So rubber, it is a genuine thing, and this thing it may not be having a similar thing. It has a different thing, maybe X, Y, or whatever. These are duplicate compressors. I think they use a different rubber. They not copy everything, so we can easily find out from this. Yeah. So what I request you is like if we can just and see that all these protections are working, like maximum motor temperature, whether the compressor is tripping in maximum motor temperature, maximum motor power. So we'll test at this point. We'll test at scroll axial unloading or floating seal unloading. So we'll test at all these points while validating the compressor. So and make sure that compressor is not failing on any of this. So compressor is protected from all these issues. So these are some of the protections we have. Internal line brake. Internal line brake is a TFD model, right? TFD model, when the motor winding temperature increases or the motor current increases, it will open. If at all you want to start, you have to wait for 1 or 2 hours, cool down, and see whether you have a continuity or not. When the winding temperature increases, the continuity will open. Yeah. Sorry. Similarly, we have discharge line thermostat in some model, external, some models, a dynamic discharge valve in some models, and we have thermodisc. So thermodisc mainly for if a discharge line temperature goes beyond particular temperature, the thermodisc open and it will switch off the compressor. In up to 6 HP capacity compressor, we have this option. Then discharge temperature thermistor we use for a bigger compressor like 20 HP to 50 HP compressor, we use discharge temperature thermistors. Then we discuss about internal pressure relief valve. So it is used up to 5 HP capacity, we use internal pressure relief valve. And we have floating seal in all our scroll compressors. And we have electronic protection, INT69 in TW. Wherever you have a TW motor code, you have this protection. Yeah. So based on the compressor model, if it is a small compressor model, small quantum, question quantum, it has a floating seal. The discharge temperature protection is taking care of this. Thermodisc will be taking care. And you have a IPR safety. There is a IPR safety valve here, internal pressure relief valve. The motor protection, it could be TFD motor, so internal line brake, right? When it goes to summit, we have a floating seal. Instead of this TOD, we have an ASTP. That is, we are going to quickly look at the ASTP. Yeah. So ASTP, we are going to quickly look at it. You don't have a safety IPR safety valve. You have to use pressure cutout, HP cutout. You have to use here internal line brake. You can have a TFD motor, or it could be a Cosense, or it could be different options available in Summit. You can have a TFD motor. You can have a TWD motor. In some places, you can have a TED motor also. Similarly, in LCS, floating seal is there. Then we have a Cosense, is what being used for discharge temperature protection. IPR is not there. Then we have 4 more sensors for the winding temperature. So winding temperature protection, we have 4 more sensors in this particular compressor. Yeah. So this is how it is mounted. The overload relay is mounted on the compressor like this, which will be sensing the winding temperature as well as the current. Okay. It is, if you are talking about 3 different windings, so it will be at the center of the 3 different windings. So when you have 3 different windings, the overload relay at the center. Yeah, it will be at the center. So whenever actually the temperature increases or the current increases, this will get open up. This is a bimetal sort of a connection, so it will, because of the heat, it goes open up. When it opens up, when you check the continuity, there won't be any continuity. Yeah, it will show light. Yeah, it won't. So you have to wait for 1 or 2 hours to cool down, then you check it. If it is happening, then it is tripping inside. So you need to find the reason for tripping and you need to take care of it. Yeah. So that's what it happened with this one. Floating seal, we already seen the floating seal part of it. And you can see the thermistor part. Yeah. Thermistor here. In some of the compressors, we have this one more sensor here. In this particular portion, we have one more sensor. In the bigger compressor, we have this. That will be sensing the discharge line temperature here. So based on the discharge line temperature, the resistance value increases. You know, the temperature increases, resistance increases. Based on that, it will be tripping the compressor. Yeah. Right. So it is like we talked about this. Sorry. It is like 143. Disconnect the motor in case of current overload or over condition. It is not 150, it is like 143. Above 143 it will be removed. Yeah. So these are how it looks when you open it. So one more thing is we have thermo disc. Thermo disc, what happens is when your discharge line temperature goes very high, so there is a bimetal disc here. There is a bimetal disc. You can see inside there is a bimetal disc. When the discharge temperature goes up, the bimetal disc opens and allow the gas to pass through. You can see the gap here. Allow the gas to pass through, and it will be directly hitting the overload relay. Overload relay, wherever you put, it will be directly hitting the overload relay. So overload relay temperature increases because of that. Because discharge gas is directly hitting the overload relay, the temperature increases. When the temperature increases, it will be switching off the compressor. Yeah. So that is for thermo disc. It is being used only up to 6 tons capacity. Yeah.
Is there any internal device for this if it is rotating for wrong direction?
What is the device you're saying?
I mean, just like any internal device.
No, actually, the compressor, this compressor could rotate in both the directions, okay, but it will be pumping only in one direction.
That is the only way to find out that one.
The way to find whether it is rotating in the opposite direction.
Yeah.
So one thing is the current will be lesser. If you measure the current will be lesser.
And
the
sound
suction and
also.
discharge pressure will be same.
And sound.
The sound will be different.
Yeah.
Even temperature, if you don't have anything, gauge and other things. Suction and discharge, if you touch and the compressor is running, you know it is rotating in the opposite direction. The sound is the easiest thing. Sound will be different.
Yeah.
Wearing the proper sound, the wrong direction, the sound will be different. So easily you can find out. And touch suction and discharge. There won't be any temperature difference much, like when it is rotating in the opposite direction. Yeah. So these IPR internal pressure relief valve. When the pressure increases beyond certain limit, for say 407C, you can say 28 bar difference. This discharge pressure and suction pressure, the difference is going more than 28 bar. This pressure relief valve opens and allow the discharge gas to go